Hi students, in this video I'll be going through the 2013 O-Level Additional Mathematics Paper 2 question 7. Alright, so let's read the question. Okay, so the diagram shows a row of material in the shape of a cylinder of radius r and length L. The row is held together by 3 pieces of adhesive tape whose width and thickness may be ignored. One piece of tape is in the shape of a rectangle and the other 2 pieces are in the shape of circles. The total length of the tape is 600 cm. Okay, so in part 1, they want us to show that the volume V cm³ of the cylinder is given by V equals to pi r squared times 300 minus 2r minus 2 pi r. Okay, so we are very familiar with the volume of a cylinder, right? So the volume of a cylinder will be basically the area of the cross section. So in this case, the cross section is a circle, okay, and the radius is r. So the area will just be pi r squared multiplied by the length of the cylinder. Okay, so over here we can actually straight away write down that V, right? V equals to pi r squared, so the cross sectional area multiplied by the length. All right, so this one we can call equation 1. Okay, but over here you see it's almost similar already. What they want us to show is V equals to pi r squared, and then this 300 minus 2r minus 2 pi r. Okay, but what we have currently is L, right? Okay, so if only we can form an equation, and then we make L the subject, and then L is 300 minus 2r minus 2 pi r, then we can sub it into equation 1, and we will be able to show what they want us to show. Right, so now that's our aim to do that, okay, to show that L is equals to this particular term over here, right? Okay, so let's read the question one more time. So over here you have a row of material. It's held together by 3 pieces of adhesive tape. Okay, so where is the 3 pieces of adhesive tape? Okay, one piece of tape is in the shape of a rectangle. So over here you can see in this diagram, where is the rectangle? Okay, so you can see that the rectangle is actually over here. Okay, followed by this length over here. Okay, then followed by over here, the diameter of the circle. Okay, then followed by finally by this length. So you have this rectangle, right? Okay, so what is the total length of this rectangle? You have R here, then over here you also have the center, R here and R here. So total is 4R. Okay, then over here you have L, right? Okay, so L and L. So 4R plus 2L. Okay, will be the length of the adhesive tape, okay, of the shape of the rectangle. Okay, so where else do we have adhesive tape? Okay, the other 2 pieces are in the shape of circle. So where are the other 2 pieces? So the other 2 pieces will be this circle, okay? Okay, so basically they wrap this material with the rectangular adhesive tape, and then to secure even further, they wrap another 2 circles around it. Okay, over here. Okay, so these 2 lengths here will be 2 pi r, right? Okay, the radius of the circle is also r. Okay, so if these 2 are circle, right, so the radius also r. So the adhesive tape will be the circumference of the circle, 2 pi r plus another 2 pi r. Okay, and this total length of all this tape is 600 cm. So in this case, we can form another equation, and this equation going to be equation 2, and then we can sub it into equation 1 to remove the L. Okay, so let's see how we can do that. Okay, so over here, we can write length of tape is equals to 600 cm, right? Okay, so length of tape is 600 cm. Okay, so what are the lengths that make up the 600 cm? The rectangle tape, correct? So over here we have R, 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 and R. Okay, so 4R plus 2L. Okay, 1L here and 1 here. Okay, so we have 4R plus 2L. Okay, plus the circumference of the 2 circular tapes. Okay, so it's 2 pi R plus 2 pi R. So 2 pi R plus 2 pi. Okay, 2 pi R plus 2 pi R. Okay, equals to 600. Okay, so all we need to do is to simplify this, and then we make L the subject. Then we can sub away the L over here. Okay, so over here we have 4R plus 2L plus 4 pi R equals to 600. Okay, so we can divide everything by 2, so we get 2R plus L plus 2 pi r equals to 300. Okay, so we are getting very close to what they want us to show already. Okay, so over here we divide by 2. Okay, then finally we bring everything to the right side except for the L. It will be 300, okay, minus the 2r, okay, then minus 2 pi r. Okay, so this will be equation 2. Okay, so you can see that we have actually managed to solve the question successfully already. Okay, we have the 300 minus 2r minus the 2 pi r. Okay, so now we're going to substitute 2 into 1, and then we have shown the volume already. Okay, so substitute 2 into 1. Okay, so V equals to pi r square. Okay, 300 minus 2r minus 2 pi r. Okay, so we have shown it already. Okay, so it's not too difficult. It's a 5-mark question, no? Okay, it's a 5-mark question, but it's not too difficult. Okay, so usually this first part of the question for this kind of maxima and minima problem, right? Okay, the first part of the question usually they require you to prove something, and to prove that thing they require some substitution. Okay, so I recap again. They want the volume, right? So volume is of a cylinder is pi r square times the length, right? The cross-sectional area times the length, okay, or the base area times the length. Okay, so now what we want to do is we want to sub away this L, okay, because the expression that they want us to show does not have L inside. Okay, so now we need to make use of the info given in the question, in this case the total length of the tape, to form an equation. Okay, and then we make L the subject, and then we sub it away from the first equation. Okay, so this is how it works. Alright, let's take a look at the second part of the question. Okay, so second part of the question is over here. It went on top. Okay, given that R can vary, show that V has a stationary value when R equals to K over 1 plus pi, where K is a constant to be found, and to find the corresponding value of L. Okay, so they say that V has a stationary value, right? Okay, so just now the equation for V was V equals to over here at the top, pi R square times 300 minus 2r minus 2 pi r, right? Okay, so now they say that V has a stationary value. So we know that at stationary value, the gradient of the equation or the graph is going to be 0, right? So in other words, what we need to do is we need to find dV dr, and then we equate dV dr to 0, and then we solve for the r, and then hopefully we can get something in this form, okay, where we will be able to identify what K is, right? Okay, so how are we going to differentiate this? Okay, so there are two ways to go about it. Either you can use the product rule, okay, whereby this one is one term and this is the other term. Okay, but for equations such as this, I very much prefer to open up the brackets first and then to differentiate each term individually. Okay, so what do I mean? Okay, so instead of using the product rule, I'll just multiply this into the brackets, okay, into these three terms. Okay, to get three different terms that are differentiate each one of them individually. So over here we will have 300 pi r square minus 2, okay, pi r square times negative 2r, so negative 2 pi r cubed, then pi r square times negative 2 pi r, so 2 pi square r cubed. Okay, so this is what we have. Okay, then we'll differentiate this. So dv over dr. Okay, so power goes in front and reduce the power by 1. Okay, power go in front, reduce by 1. Power go in front, then reduce by 1. Okay, so we have this expression for dV dr. Okay, so at the stationary value of V, okay, so at stationary V, okay, dV over dr equals to 0, right? Okay, so we're going to equate that whole thing to 0. So 600 pi r minus 6 pi r square minus 6 pi square r square equals to 0. Okay, so over here we can see that there's a lot of 6, right? So we can actually divide throughout by 6. Okay, so divide by 6, but there's also a common factor of pi. Okay, so we can divide by pi also, 6 pi. So this one will just become 100 r. So we are dividing by 6 pi, so this just becomes r square. Divide by 6 pi, pi r squared equals to 0. Okay, so you may be wondering, there's also a common factor of r, right? Okay, but when you do solving equations such as this, you should never divide throughout by the variable. Okay, if not, you may end up losing some solutions. Okay, so r is the variable here, so never divide throughout by the variable. Oh, you can only divide throughout by numbers and constants. All right. Okay, so from here, we're going to factorize out the r. So we get 100 minus r minus pi r. Okay, so we get this. Okay, so if we have a times b equals to 0, then it's either a equals to 0. Okay, in this case, either r equals to 0 or 100 minus r minus pi r equals to 0. Okay, so we need to reject this. R can't be 0. R is the radius of the cross section of the material, right? So if r is 0, then okay, then there will be no material in the first place. Okay. Okay, so over here we just need to solve for r. Okay, so we're going to bring r and pi r to the other side. Okay, then we're going to factorize out the r. Okay, I'm going to switch side. Okay, I prefer to have the variable on the left side. Okay, so I'm going to factorize out the r, so get 1 plus pi equals to 100. Okay, then indeed we are able to express in that form. Okay, so you can see the form that we want is k over 1 plus pi, right? Okay, so now we have gotten 100 over 1 plus pi. So in other words, by comparison, k will be equals to 100. Okay, right, but that's not the end of the question. They want us to find the corresponding value of L. Okay, so all we need to do is to sub the r that we have found. Okay, sub the r that we have found into this particular equation over here, and then we try to simplify. Okay, so L equals to 300 minus 2r minus 2 pi r. Okay, so let's do that. So L equals to 300 minus 2r minus 2 pi r. So we're going to substitute the r inside. So 2 times 100 over 1 plus pi minus 2 pi times 100 over plus pi. Okay, so over here, so you get 300 minus 200 over 1 plus pi, okay, minus 200 pi over 1 plus pi. Okay, so you can see that the second and the third term, they have the same denominator, so we can actually combine them together. Okay, but before we combine, I would like to factorize out the negative sign. Okay, factorize out the negative 1. Okay, so this such questions need to practice. Okay, how to simplify the particular expressions, and this requires you to have a good basic foundation of algebra and math. Okay, so same denominator, so we can combine it together. So we get 200 plus 200 pi. Okay, then from here you can see that we can actually factorize out 200 from the top over here. Okay, so you get 300 minus. Okay, so over here going to factorize out 200. So we get 1 plus pi over 1 plus pi. Okay, which means that the 1 plus pi can cancel off. Okay, from here, this one can cancel off. Okay, so we are left with 300 minus 200. So the answer for L will also be 100. And so I would say that this second part of the question is actually rather difficult to manipulate. Okay, it's not easy to manipulate. Okay, but as long as you know the basic concepts, okay, for example, how to differentiate V, okay, and how to differentiate more easily, we should open the bracket first before we differentiate each term individually. And then extension value of V dV dr equals to 0. And then you try your best to solve for R. Okay, so this one requires a lot of practice in order for you to become confident at manipulating equations like this. Right, but I believe with practice, you should be able to do it.